Bismillahirrahmanirrahim. Hello students, welcome to the Electrical Engineering YouTube channel. In today's lecture, I am going to discuss bisection method for solving nonlinear equations to find out their roots. Bisection method is based on intermediate value problem. If there exists a continuous function f of x in the interval a to b and c is any number between f of a and f of b, then there exists at least one number x in that interval such that f of x is equal to c. So in this bisection method, we have to find out the root of a nonlinear equation, and the nonlinear equations are those algebraic equations which cannot be solved by conventional analytical methods. For example, if we have the equation x square e raised to power x is equal to 5, or if we have an equation x square sine x is equal to 10, then such an equation is called a nonlinear equation because we cannot simply find out the root of such equations. So the root finding of such equations can be done by solving these equations iteratively. So there are several methods which can be used to iteratively find out the roots of such equations, and one of those methods is called bisection method. Okay, so in bisection method, we have to first find out the mean value of these 2 points, and we are sure that the solution exists between these two boundary points because the value of the function at one point is negative and the value of the function at the other point is positive. It means it is essential that the solution exists between these 2 points. Then we will take the average of these 2 points a1 and b1, and we will get c1. So this is point c1. Now we will check whether our solution lies in this range or in this range. So clearly the value of the function at this point is negative and the value of the function at c1 is also negative. It means the solution doesn't exist between points a1 and c1, and the solution essentially exists between points c1 and b1. Now this point is our a2 and this point is our b2, and this is our new range. Again we will repeat the same step, and we will take the average of a2 and b2, and we will get point c2. So this is point c2. Now we will check whether our solution lies in this range or in this range. So clearly the value of the function at point c2 is positive and at point b2 is also positive. It means the solution doesn't exist in this region, and the solution essentially exists between points a2 and c2. So this will be our a3 and this point will be our b3. Now again we will take the average of points A3 and B3 and we will get C3. Again we will check the region in which our solution exists. So clearly the solution exists in this range, and you can see this is the actual solution X, and we are slowly approaching towards our accurate solution. So this is how bisection method works, and by following this ideology, we will try to develop the MATLAB code to solve nonlinear problems using bisection method. So in bisection method, we will take the average of 2 points a1 and b1. So it will be given as c1, and it is equal to a1 plus b1 minus a1 over 2, and it will be equal to a1 plus b1 over 2. This is the flow chart of the bisection method, and this is a very simple and brief MATLAB code which can be used to solve the nonlinear equation. So nonlinear equations are those equations which cannot be solved by conventional analytical methods, and such equations, example of such equations is x square x e raised to power x equal to 10. So okay, so this is one example. Similarly, x square sine x equal to 5. So in such equations we cannot separate the value of x to find its value. So such equations can only be solved iteratively, and these iterations should be carried out in a logical way, and there are several algorithms which can be used to find the roots of nonlinear equations, and bisection method is one of those algorithms. Okay, so this is our algorithm, and here we will define our function. So f is equal to at x square minus 0.5. So this is a linear equation. This can also be solved using bisection method, and we will also uh, solve some non-linear equations. So we will specify the initial values of the range. So we have first specified the range, and we will check whether our solution exists in this range or not. So A is equal to 0 and B is equal to 1. And we have specified the tolerance of 0.001. It means if we get the root whose value is less than 10 raised to power minus 3, then we will say that we have actually found out the root. Otherwise, the iteration will be going on. So this is the I equal to 1 variable, and this variable is used to calculate the total number of iterations in which the solution has been obtained. So we have specified the error initially as 1, and we will check the error after every iteration, and when this error becomes smaller than the tolerance value, we will terminate our loop and we will print the solution. So first of all, we will check if our solution exists between these 2 points A and B. So we have calculated the value of the function at first point and at the second point, and we have multiplied them. Definitely, if the product is less than 0, it means the solution exists between points A and B. So if the value of the function at first point is positive and the other point is also positive, it means there is no value of x at which the value of the function is equal to 0. So from this graph, you can see this is our first point, this is our second point. If the value of the function has opposite signs for the 2 points, then it means the solution exists between these 2 points, and the solution exists where the value of the function is equal to 0. If the value of the function at this point is negative and the other point is also negative, it means there is no point in this range at which the solution exists or at which the value of the function is equal to 0. Similarly, if the value of the function at both the points is positive, then again the solution is not lying between these 2 points. So the sign of the function at the 2 points must be opposite. So their product will be negative in this case, and it will be less than 0. So we have used a while loop, and we have put the condition that the error must be greater than the tolerance, and we have obtained the mean value or average value of these 2 points, and we have used this if condition. And according to this condition, if fb multiplied by fc is less than 0, it means the solution exists between points b and c. So in this case, the point a will be discarded and the point c will become our new point a. And otherwise, if f of b multiplied by f of c is greater than 0, it means the solution exists between points a and c. So in that case, we will discard point b and we will assign the value of c as the new b point. With every passing iteration, we are converging our range, and in each iteration we are also calculating the value of the function. And if the value of the function becomes less than the tolerance, then we will terminate our loop and we will display the root of the equation. And if this if condition becomes false, then it means our these two initial guesses are wrong, and we have to specify new initial guesses. So in that case, in the command window, this statement will be printed out, and this statement is the guess is incorrect. So this code will also show us the total number of iterations in which the solution or in which the algorithm has converged. So let's run this code. So you can see the code is written over here, and initially I have such a function x square exponent x minus 5, and I am going to find out the root of this equation. So let's run this simulation and click on add to path. So here you can see that the solution has been converged and the total number of iterations are 15 in which the solution is obtained, and the required root of the equation is 1.2169. So again I can change the range of this equation, right? So the solution is this. So if I specify a to be equal to 2, so definitely our solution doesn't exist between 2 and 5. So let's see what does it say. So it will say that the guess is incorrect. So this range must contain the actual solution. So if we get such a result, we have to change the range of the solution. So again, we have obtained the same answer but in smaller number of iterations. So this is how it works, and we can also change our function to any value, right? For example, x squares sine x, and let's run this file. and we will see that the guess is incorrect. So let's change the range now. So I have assumed a equal to 0. Again, the guess is incorrect. So let's increase the range more. So let's make it 50. Again, the guess is incorrect. Now let's make it minus 50 and make it 500. So you can see the required root of the equation is minus 34.5617, and it has taken 28 iterations. So we can do more exercises, and we can find out the roots of several equations. So if I consider this function x square exponent x minus 5, so I have already tried this function. Now I will try x square exponent 2x minus 5. So it will become exponent 2x minus 5. Now let's make the range of 0 to 10 first, and let's try to run this file, and the root is 0.9047. So from this manual you can try other values as well, and you can try these ranges, and for each range you will get the correct answer. So if I specify x square e to 2x minus 5 for a is equal to 0, b equal to 1. Now let's see what result we obtain. So 0.90479 and 11 iterations have been taken by the algorithm. So this is all about our today's lecture. I hope you have understood the concept of using the bisection method for root finding problem and for solving nonlinear equations. For watching more similar videos, please stay tuned to this YouTube channel. Until the next lecture, it's goodbye.